It doesn't really matter. Okay, so there are two types of trapezoids. Non-isosceles, which I would just call a trapezoid, and then an isosceles trapezoid. What you need to know about trapezoids and what makes them a trapezoid, it's a four-sided figure, it's quadrilateral. But the key thing is it only has one pair of opposite sides that are parallel. So as long as you know that two sides are parallel, it's a trapezoid. Now what makes an isosceles trapezoid different, think of like an isosceles triangle. How many legs or how many sides are congruent? Two, right? So our legs here are congruent, which makes it an isosceles trapezoid. Some things to know is we call the parallel side our bases. So base on the top and the bottom. I guess that's not plural, it's just the base. And then the two sides that are not parallel are your legs. On an isosceles trapezoid, your base angles are congruent, so this angle in this corner is congruent to this angle in that corner. And similarly on the top, this angle up here is congruent to this angle up here. And then one more thing we need to know. These angles are supplementary, as are those. Same with these guys. They add to 180, and those add to 180. So this angle, let's say this was 80 degrees, this one would have to be 100. These two angles are supplementary, and so are those. Consecutive angles are supplementary. What's that?
Put a smiley face in second too.
Oh, yeah, there you go. Okay, so let's try to find some missing angles. Let's just practice. What kind of an trapezoid is this? Isosceles or non-isosceles?
Non-isosceles.
Perfect. And just remember, these angles on top of each other have to add to 180. So what would be an easy way to find the measure of angle M?
180.
Yep, 180 minus 87.
90.
90, 30.
97. 93.
Same thing with this guy, minus 51. 129. Brownie points. What kind of angles are these? They're supplementary, but remember from like chapter 3, it had special names or alternate interior. Alex?
Oh, that. Oh, you're talking about that.
Anyone know?
Consecutive interior.
Consecutive interior, good job. Yep, that's why they're supplementary, because they're two parallel lines. Okay, who has a plan to find the measure of angle R?
12x plus 3 plus 7x minus 13 equals 180.
Yep, these two expressions have to add to 180. You guys start solving. I'm going to walk around with calculators quick.
I mean, you can't. Yeah. I played a game where
That's probably
took another job last
What did you guys get for x?
10.
10. Now plug back in to find the measured angle r.
70.
What's 70 minus 13, folks?
57.
Nice work. Good job. Okay. We are given, this is an isosceles trapezoid. So what is DG congruent to? EF. And I forgot to mention this, so I apologize. Your diagonals are congruent in an isosceles trapezoid. So DF is congruent to GE. Perfect.
Why do you skip this?
Okay, now let's decide what kind of a trapezoid is this. Isosceles. So we know base angles are congruent. So what other angle is 47 degrees?
W.
W. And then again, these guys are supplementary. So what would we get for angle W or Y?
133.
And Z would be congruent to Y because they're base angles as well. Good job, folks. Okay. Now we have the mid segment of a trapezoid, and it just connects the midpoints of your legs. So my mid segment of this trapezoid here would be EF. And I know these are the midpoints, E and F, because this is congruent to that, and 2 tick marks is congruent to those 2 tick marks. So if you know you have a mid segment, sometimes it's called a median, depending on what textbook you use, then the bases would be parallel to the mid segment. That's what this line is here. AB is parallel to EF, and EF is parallel to BC. And we can find the length of the mid segment given this formula. So EF, that's your mid segment, equals your bases AB plus DC divided by 2. So if you were given the lengths of your two bases, just add them together and divide by 2, and that would give you your mid segment length. I think we have some pretty nice little problems here to try. So is that a mid segment of that trapezoid?
Yeah.
Yeah. So to find the length of it, 7 plus 11, all over 2. 18 over 2 gives me 9, like Colby said. And if you look, this is 9. How big of a jump is it from 7 to 9? 2. And how big of a jump is it from 9 to 11?
2.
It should be equal. Those should be equal distances. So how can we find out what a missing base is then? Gabby, that equal distance. That's how I would do it. Yeah. What's the distance from 6 to 10? Minus 6. And then how could I find x? Minus 6. So 10 minus 6 is 4. That's it.
Would you be able to do that algebraically as well?
Mm-hmm. Just plug into the formula. 16 plus x over 2 equals 10. How do I get rid of that 2? Multiply out. Equals 20 minus 16x equals 4. So it works. Either or. However your brain works. Okay, now let's try it with some expressions. So still set up the same way. Use your formula. So this is what our mid-segment is. So I'm going to put 5x minus 19 equals my bases added together. So I have to add these two together and put it over 2. Is that part confusing? You guys see where I got that formula?
No. Yes.
Yeah, you're good.
It's not confusing. Yes.
14 plus 38 gives me
52.
52 over 2. I don't like working with fractions, so I always get rid of it. How do I get rid of divide by 2?
Multiply by 2.
Multiply by 2. Then I take this whole thing times 2. 10x minus,
38.
perfect, those just cancel. Bring our x over, plus 38. What do we get? We get 90. Perfect. Perfect. Nice work, folks.
Find the measurements.
Just plug that in. Yeah, we're done. We'll find x right now. So that's trapezoids in a nutshell. Should we go on to kites, our last one for the chapter?
Maybe we could.
All right, go with the right K for you. So kites are weird because they don't really follow any of the other patterns like our other shapes do. But we have 2 pairs of congruent sides. So AB is congruent to AD, and BC is congruent to DC. 1 pair of opposite angles are congruent. So do you guys see where the 2 congruent sides meet?
Yeah.
So this is where they meet here, and this is where they meet here. Angle B and D are congruent. Those are your 2 congruent angles in a kite. Why is that true? Does anyone know? I'm just looking at that example up there. Do I have any congruent triangles in this?
Yes.
Yeah.
Do you guys see? Look, AB is equal to AD, BC, DC, and then don't they share AC? Right? They share in the middle. So by side, 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 this top triangle is congruent to that bottom one. So that's why those 2 angles are congruent. Little fun fact. Okay. And then just remember your diagonals are perpendicular. So what kind of angles are in the middle? 90.
Yeah.
Okay. Let's try find some angle measures in a kite. Let's start with the obvious one. What is 3?
90.
90. Is there another angle that is 52 degrees? Yeah. So remember, this bottom triangle is congruent to this top one. So just it's a reflection, really. So if this is 52, then this guy's 52.
Would that mean that 465?
Yep, 465. Four is 65. Then do you see how you have a bunch of little triangles in there? Right? So if I wanted to find one, that's 90 degrees. So 180 minus 90 minus 65 will give me 1.
5.
Yep. 25. One's 25. What's another one that's 25? 2. How can we find angle 5?
Well, 7 equals 52, and then the opposite of 3 is going to be 90.
Yeah. So just subtract from 180. And we get 38. So then 6 is also 38. Any questions with that, guys? All right, one last example here. We have a kite, and we are given WX is 14, WR is 8, and we want to find RZ. What's RZ congruent to?
RX.
RX. Can I find RX?
Pythagorean
Pythagorean theorem. What do we get? 5. 132. 11.48 to 11.5-ish. Happy Friday, guys. Made it. We made it. I'm gonna apologize.